Doppler effect. This becomes an easy section once you understand the concept. Here is the famous equation for the Doppler effect, and you can use it in two ways, which we'll see later on. Red means further away, and blue means closer. This is for more of the theory type of questions which we will go through. Towards, you use a plus and a minus, and away a minus and a plus. This relates to the formula. If something is moving towards you, you use the plus and the minus. If something is moving away from you, you use the minus and the plus. So you just switch them around. Some uses of the Doppler effect: the Doppler blood flow meter, speed taps, heartbeat of a fetus. The standard answer for something that is moving away or towards you is here. The spectrum of a distant star moves away from Earth towards the red end of the spectrum, and the lower the frequency, the higher the wavelength. This just shows you that the more compressed means it's going toward you. So if you get a diagram like this and they ask you, which way is this car going? Wherever there's the most compression is the side that it's going. Moving on to past papers so you can get the hang of the questions. A little boy has been given a remote control car for his birthday. It has a red light on top and a siren that produces a single note with a frequency of 265. When playing with the car, the boy notices that the frequency of the note produced by the siren seems to change as the speed and direction of the car changes. Take the speed of sound in air at speed 340. State the Doppler effect in words. This is something you have to by heart from the guidelines. It's nothing I can physically teach you. On one occasion, the car is moving away from the boy. As it slows down and stops, he notices that the frequency of sound changes. Explain the change in frequency that the boy hears as the car slows down and stops. As the car is moving away from the observer's frequency will be lower than the source's frequency. As the car slows down, the observed frequency increases until it is equal to the original source frequency. Explain why there's a noticeable change in the frequency of the sound from the siren, but not a noticeable change in the color of the red light as the car changes speed and direction. This is very simple and is because the speed of sound is very much lower than the speed of light. The speed of light is very fast. Doppler is only noticeable if the speed of the source of sound is relatively close to the speed of the wave. Hence the effect is noticeable with sound but not light. Calculate the frequency of the sound heard by the boy as the car is moving towards him at a speed of 15. So we are calculating the speed of the sound heard by the boy. So you use your equation. It says towards, so you put a plus at the top and a minus at the bottom. You're working out the frequency of the listener, meaning the boy. 340 plus 0, 340 minus 15, because they gave that to you in the question, and 265 because it is here. That's the frequency of the source. And you just solve for your frequency of the listener. Write down 3 uses of the Doppler effect. This was in my previous slide, so I'm sure you will want to by heart it. As you can see, it is in the past papers. Measure of the blood flow rate, observation of the fetus heart rate, and maybe radar monitoring of speeding cars. Let's do another example. A siren of a stationary police car emits sound with a frequency of 300. The speed of sound in air is 340. State the Doppler effect in words. Again, you get this from the guideline, however, it is on this example if you want to take note of it. Calculate the wavelength of the sound waves. The wavelength equation is in your datasheet that you will be given. Here's the definition if you want to take note of it, and this is how we calculate wavelength. 340 because they told us the speed of sound in air is 340, and 300 because that is the sound that the police car emits. And you just solve for wavelength, making wavelength the subject of the formula. Write down one application of the Doppler effect in the medical field: to monitor the heartbeat of a fetus or to measure the rate of the blood flow. I would like you to pause the video and try this past paper yourself. However, if you are struggling, watch it and then go back when you are revising to attempt it yourself. An ambulance with its siren on is moving at a constant speed of 20. The siren emits sound waves at a constant frequency. The stationary detector placed on the side of the road records a frequency that it is 50 higher than the original frequency. Take the speed of sound in air as 340. Name and state the phenomenon described above. We all know that is the Doppler effect. Is the ambulance moving away or towards the detector? It is moving towards because the frequency is higher than the original frequency. Calculate the wavelength of the sound emitted by the siren. We use the normal equation. However, you have to minus 20 because it is going towards. So you put the plus at the top, the minus at the bottom, you're minusing 20 because they tell you that. And the frequency of the listener is basically the detector that is placed on the side of the road. You have to add 50 to it because they told you it's higher than the original frequency of 20. So now you just solve for your frequency, the source, and you take that amount and you put it into the wavelength equation showed in the previous example, and you solve it. Will the frequency of the reflected sound waves as received by the ambulance be equal to, greater than, or smaller than the frequency recorded by the detector? Give a reason. The answer would be greater than. The reflected waves are moving towards the ambulance, thus it will be greater. And they also told you in the question it would be 50 higher, meaning greater than.